Okay, this time around we're going to take a closer look at arithmetic sequences, and what we want to do is come up with a formula that will give us the nth term of an arithmetic sequence and be able to use that formula to find specified terms in the sequence. So we already talked about what an arithmetic sequence is. It's a sequence of numbers where if you subtract any two consecutive terms in the sequence, you get a common difference. Or another way to think about it is as you move down the sequence or to the right, you're adding the same number each time. So I've got a sequence here where we add 4 each time. So it's arithmetic with a common difference of 4. And what if you needed to know the hundredth term? So the first term is 3, the second term is 7, the third term is 11, the fourth term is 15, and that pattern will continue. And what if you needed to know what the hundredth term was? Well, I doubt you would want to sit and actually write down all 100 terms to figure out what the hundredth one is. I know I wouldn't want to do that. So there's got to be a quicker way to come up with what would be the hundredth term, or the 500th term, or the 4,000th term, or whatever term you're interested in. Well, let's see if we can't come up with a quicker way. We know that the first term is 3, and we would just add 4 to get to the second term. And I would add 4 to get to the third term, and I would just keep adding 4 until I got to the hundredth term. So if I just start with the first term, 3, and I add 4, well, how many times do I have to add 4 to get to the hundredth term? Well, I add 4 one time to get to the second term. I add 4 two times to get to the third term. So if I add 4 99 times, I should get to the hundredth term. So to find the hundredth term, I could just take 3 and add 4 99 times, which would tell me that the hundredth term is 399. So that would be a pretty quick way to come up with the hundredth term. Just take the first term, and then we're going to add 4 99 times to get to the hundredth term. Well, that was for that particular sequence. So what if we wanted to do this for any arithmetic sequence? So it turns out if you want the nth term of an arithmetic sequence, so like we just did the hundredth term. So, if you want the nth term, so n could be any positive integer, we just did the hundredth term, you would just take the very first term in the sequence, and then you would add n minus 1 common differences. So we wanted the hundredth term, so we took the common difference 4 times 99. 100 minus 1 would be 99, as the example we just did. So in general, if you want the nth term of an arithmetic sequence, you just take the first term plus n minus 1 times the common difference. So just to see this work again, let's find the 17th term. So 5 is the first term, and if you look closely, the common difference is 3. We're just adding 3 each time. So if I want the 17th term, so t sub 17, which means the 17th term, I'm just going to take the first term. So here, to learn a formula, you just write it down anytime you use it. That helps it stick in the brain. So the nth term is the first term plus n minus 1 times the common difference. So if I want the 17th term, it'll just be the first term, which is 5, plus 17 minus 1 times the common difference, which was 3. So the 17th term in that sequence, if I wrote them all out, would be 53. That one's easily checked because 17 terms isn't that many, so you could just keep adding 3 until you got to the 17th term and double check that it really is 53. Okay, let's go ahead and look at a slightly more difficult one. So we were asked to find the 23rd term of an arithmetic sequence whose second term is 4 and whose fifth term is 22. So they don't tell us what the first term is. They don't tell us what the common difference is. All they do is tell us that it's arithmetic and we know two of its terms. So let's just write down what we do know. So we know that the second term is 4. So t sub 2 is 4. Well, we know that the nth term for an arithmetic sequence is the first term plus n minus 1 times d. Well, we know they're telling us here that that the second term is 4. So 4 should equal the first term plus 2 minus 1 times d. If we simplify, 4 equals t sub 1 plus d. So this 2 right here, that's our n. So we just plug that in for n. And then we know that the term is actually 4, so we plug in 4 for the term. And we see that 4 should equal the first term plus the common difference, which we don't know what either one of those is. Thankfully, they told us that the fifth term is 22. So the fifth term is 22. So if we plug that in, let's see, the nth term is the first term plus n minus 1 times d. That's our formula for the nth term of an arithmetic sequence. We know that the term is 22. We know that n is 5. And if we simplify, we get 22 equals the first term plus 4 times the common difference. So I still don't know what the first term is, and I don't know what the common difference is. But I do have two equations that both use t sub 1 and d. So we can write a system of equations where t sub 1 plus d is 4 and t sub 1 plus 4d is 22. Now you can solve this system however you would like, whatever your personal preference is. As you may remember from when we studied systems earlier this year, I prefer elimination. So I'm going to take this system and I'm going to leave the first equation alone, but I'm going to multiply the second equation by -1. And then I'm going to add those together. So t sub 1 plus negative t sub 1 is 0. D plus negative 4d is negative 3d. And 4 plus negative 22 would be negative 18. So the common difference must have been 6. So now we know that the common difference of this arithmetic sequence is 6. Well, if I plug 6 back into the first equation, t sub 1 plus 6 should equal 4. So the first term must have been negative 2. So now I know what the first term is, and I know what the common difference is. So they asked us to find the 23rd term. So the 23rd term should be the first term plus n minus 1 times the common difference. So negative 2 plus 23 minus 1 times 6 tells us that the 23rd term must have been 130. So the 23rd term of that arithmetic sequence is 130. Okay, last thing we're going to talk about is what an arithmetic mean is. So an arithmetic mean, by definition, if you're given two real numbers, a and b, so we'll have a and b be our real numbers, their arithmetic mean, which is fancy speak for an average, so their average. So an arithmetic mean just means average. Their arithmetic mean, you just add them up and divide by 2, because that's how you find the average of two numbers. You just add them together and divide by 2. So for example, if I ask you to find the arithmetic mean of 4 and 9, well, you just find their average. So 4 plus 9 divided by 2 is 13 halves, or 6 and a half. So the average of 4 and 9 is 6 and a half. Well, that's not very interesting, but it turns out it's related to arithmetic sequences. So arithmetic means. So what if you have, when we say arithmetic means, so that's plural. So let's say you're given an arithmetic sequence. The numbers between any two terms are called the arithmetic means of those two terms. So for example, say you have this arithmetic sequence, 10, 13, 16, 19, 22. So we're just adding 3 each time. Well, if I pick 10 and 19, so say I pick 10 and 19, so I pick those two terms. So I'm going to pick 19. Well, the two numbers that come between them are the arithmetic means between 10 and 19 for that arithmetic sequence. Well, what if I pick 10 and 22? Well, if I pick 10 and 22, then 13, 16, and 19 are the arithmetic means between 10 and 22. So if I pick any two numbers in the sequence, the numbers that come between them are called the arithmetic means. Well, if I pick two terms like 10 and 16, the one number that comes between them is the average of them, is the arithmetic mean. So if there's only one number between them, that's just their average. So you can give it a try. 10 plus 16 is 26, divided by 2 is 13. So if there's one number between them, that's the average of the two, or the arithmetic mean. And if there's more than one number between them, it's called the those are the arithmetic means between those two numbers. All right, so let's use this idea. Let's say we're asked to insert 4 arithmetic means between 15 and 50. So that means we have an arithmetic sequence, and all we know about it is we've got the number 15. So we don't know if that's the first term. We don't know what term that is. So there might be some terms before it, but we know there's a 15, and then we want 4 arithmetic means between them. So there's going to be 4 digits that we don't know, but then there's going to be a 50, and then there might be some terms after it. We don't know. So all we know is that 15 and 50 are part of the arithmetic sequence, and we want 4 arithmetic means between them. Well, since we don't know what comes before or after, and we're not really interested in what comes before or after, what we're going to do to find these 4 arithmetic means is we're just going to say, well, since we don't really care what comes before or after it, let's just call this the first term. Then this would be the 5th term. And let's see how that helps us. So the first term is 15, and the 5th term, it would help if I could count. So that's not the 5th term. Let's try that again. That would be the 6th term. So 1, 2, 3, 4, 5, 6. That'd be the 6th term. If I could get my counting correct. So the 6th term is 50. So let's see. We know that the nth term is equal to the first term plus n minus 1 times d. Well, we know that the 6th term is 50, so 50 should equal the first term plus 6 minus 1 times d. So 50 should equal 15 plus 5d. So 35 should equal 5d. So the common difference must have been 7. So that means I should be able to add 7 each time to get the missing 4 terms that we want. So we can now find those 4 arithmetic means. So we have 15, add 7, add 7, add 7, add 7, and then there we go. There's the 4 numbers that we wanted.